Last time we looked at sum and difference identities. Here we're looking at double angle identities, which are exactly what you'd think they are. Identities for twice an angle, double angle identities. This is set up with some questions to have you think about it here, the same as before. I've asked you to copy them out off your sheet, which you can do at some point. Maybe I'll actually just write them for you here. There's 3 equal signs here because there's a bunch of versions for the one for cosine of twice an angle. Again, I want you to realize what this is. This is, because people don't always put brackets here, it's cosine of twice an angle. Okay, so it's looking at something like cosine of twice, I don't know, an angle here, 37 degrees. And it's looking at how is that related to the trig ratios for, so in other words, cosine of 74 degrees. It's looking at how is cosine of 74 related to cosine and sine of 37 degrees. Okay, so that's what these are all about here. Sine of 2 theta here is the same as 2 sine theta cos theta. That's just what it is. Okay. This is just what it is here, right? I think some people. I want you to look at that and think about it for a second, and then maybe ask some questions that you might want to ask. Anybody have any questions there about this one? I think for some reason grade 12s would be more comfortable if it looked like this. Because then, of all these years of teaching it, I've tried to put myself in how a grade 12 student seeing that for the first time, what they think. This is not true, right? There is a cosine of theta here, but I think if this wasn't here, grade 12s think, oh, that's okay, I'm just factoring out the 2, right? You can't factor something out of a trig function. You're not factoring anything out. It's equal to this. You can test it on your calculator. It's the same as anything. Y is, y when you have a triangle is, 3 squared plus 4 squared equal to 5 squared, a squared plus b squared, c squared. It just is. That's the way it is, right? You test it for any possible angle. You can prove it's true. You can prove that this is true. Okay? Given what we already know, we're going to prove that is true in a second here. There are, for cosine of 2 theta, there's a similar one here. Well, it doesn't look anything alike, but it looks like this. And it actually looks pretty similar to another identity that you know. We'll get to the other 2 in a second here. We'll leave those blank for a little bit here. I do want you to see where these ones come from, because you can see where they come from based on what you know about sum and difference identities. So we're going to skip ahead here a little bit. This is for you to think about after. But this is kind of generating them from what you already know. Okay, general approach here to showing why these are what they are. We're going to start with, we'll do one of them here. Start with the addition identity for sine. So sine of alpha plus beta, if you remember what that was. Anybody know it off the top of their head? Sine alpha cos beta. That's good. The thing that you do here, though, is if you want double an angle, what you can do is just make both of those angles the same. Instead of sine alpha plus beta, you could call it sine theta plus theta, the same angle there. Okay, make them the same. Because then theta plus theta, how can we write that instead? Yeah, 2 theta, right? X plus x is 2x. You can open the door and maybe just tell them something. Says you can come in, but really mad. I should freak out. Okay, so what do you get when you do this? If you have sine theta plus theta, can you right now write out what you get here? What does this look like if you make both the angles the same? And then how could you simplify it? Okay, that's what you're doing right now. What do you think? What do you get here? You have, you can write sine theta cos theta plus, oops, what did I do up here? Is this your problem? That you're confused why I wrote cosine twice up there? What should this be? That should be sine here. I wrote that. Let's not always blame. What can you do with this though? If you're ever not sure what to do with something that involves trig functions like that, if you don't know how to simplify it, just think about what if these were each a variable. So if this said mn plus nm, what could you do with that? Yeah, they're the same, right? Because nm is the same as mn. You can put them together, and what would it be? Yeah, two of those, right? So what you have here is you have 2 sine theta cos theta. That's that identity that I wrote for you on the first page, right? That's what it is. You can see where it comes from these. You can do a similar thing for cosine. I'll leave you to do that for yourself, but it's going to look different. It's going to look like what we had on the first page. You can do that for yourself sometime. All right. Other things we're going to do with this is you can change once you get this one, you should end up with here with what we had on the first page, which is cos 2 theta is cos squared minus sine squared. Okay, when you go do that, or when you copy it off your formula sheet, it looks very similar to which other identity that you have? Yeah, this plus this equals 1, right? So you got to be careful with that. If it's cos squared minus sine squared, it's different than cos squared plus sine squared. Okay, it's similar to that one that equals 1. The other ones here, if you're looking at this formula sheet, maybe I should show you where. I keep talking about this formula sheet, maybe you're not sure where I'm talking about here. There's this is the identity that we just had. Sine 2 theta is 2 sine theta cos theta, but there's 3 different ones for this. The first one is the basic one, or the main one. But the one underneath here, these are just if you take and substitute this Pythagorean identity up here, if you use that to replace either the cos squared or the sine squared. So if you use this one in combination with this one, you can generate those other two. That's what's happening here, right? Like if you take that one now, but you replace cos squared with if you replace sine squared, follow my own directions there. What can I replace sine squared with? What's sine squared the same as? Yeah, 1 minus cos squared, right? We have, you can replace sine squared with 1 minus cos squared, right? Using that Pythagorean identity. You can substitute that. What do you have when you do that? You have cos squared theta minus 1 minus cos squared theta. What do you end up with here? You get rid of those brackets. Don't make bracket mistakes here. Minus 1, what goes over here though? Plus cos squared. If I have to simplify that, what does that simplify to? Didn't leave myself enough room here. Maybe we'll do this. What does that simplify to? Yeah, 2 of them, right? Cos squared minus 1 plus cos squared is 2 cos squared theta minus 1. So that identity is one of the ones on the sheet, right? That these are equal. You have cos 2 theta can be this, or it can be, a similar thing here. You could do the same thing here and get the other one that's on that formula sheet. If you look back at the formula sheet, there's this one as well. That can be one that you do for yourself after. All right? So that's kind of generating those identities. There's questions up here that you should answer for yourself as you work through this. I know some people are kind of skipping all of this stuff and saying, this is all, I don't want to do this. This is a waste of time. I'm just going to get down here where it says check your understanding somewhere. So they skip all of this, and then they try to do this. I had students in my A block. I know you guys would never do this, but who come and say, "Oh, can you help me with these questions? I need some hints." And I said, "Well, there's questions here that are just the same. They're questions, and look, there's already hints here. That's the idea behind this. Is before you kind of check whether you understand, you actually do something to understand. So work through these, read some of the hints, and you'll get it. Okay? We will do a couple of these things together here, but I better stop this first.